Hi, everybody, and welcome to SurrealDB stream number 21. We are here today with Rushmore and Raphael. My name's Lizzie Holmes. I'm head of operations here at Surreal, and great to be back on one of the streams today. So today we are diving into how to contribute to SurrealDB. We're also going to be diving right into the code base and also talking more generally about how to contribute to open source. It's really exciting to be joined by Raphael and Rushmore. They were two of the team members that joined us right at the beginning. Rushmore, you were literally our first engineering hire. So we had Jamie and Toby, obviously our co-founders, and I joined the team. And we heard about this amazing, amazing guy who was contributing so much to Surreal. How did you first hear about SurrealDB? You're on mute, classic mute. There we go.
Yeah, so I saw the announcement for beta 8 on Reddit. I think it was in 2022, was it? Or 2023? I don't quite
2022,
remember.
yeah.
Yes. So I've always said a thing for databases and Rust. So databases in Rust was obviously something I was going to jump on. I had already all the various projects that were doing databases in Rust under my radar. But when SurrealDB came out, it spoke to me like in its feature set, like what it was trying to do. So yeah, I was hooked right from the beginning.
We love that. And actually, for anyone who is watching, I know we're going out all over Twitter, LinkedIn, and YouTube. So do share where you're watching in from. Rushmore, you're obviously calling in from Zimbabwe. We're here in London. And also let us know when you first heard about Surreal and how much you are all contributing to open source. We can see all the comments coming in. And also, of course, a reminder, if you've got any questions, please do post them throughout the stream, and we'll be able to answer those, Rushmore and Raphael, as we go along. So Rushmore, you're one of our senior software engineers, and then we also are welcoming Raphael Dali today, who you also kind of came into Surreal's life right early on. You are our engineering intern. And you were saying, Raphael, you did a stream about us, about Surreal, I think in September 22. So how did you first hear about?
Yeah,
about
I mean, I think it was a similar sort of thing, seeing other videos on YouTube, Reddit, and other people talking about it. And I think I forgot about this, but I was just trying to figure out when it was. At the time, I was doing something in MySQL, and I heard about this amazing new things that was solving some of the things that I was fighting against. And so I decided to check it out, and I did some streams, and I've been excited and sort of initially was made some PRs against the docs, and then eventually started doing some stuff in the actual database itself.
Amazing. So before I hand over to you both, Rushmore, maybe you can just take us through like how we can contribute and the different ways that we can contribute.
Yes, so there are various ways people can contribute. Obviously, software engineers can contribute code if they want. They can report bugs. Also, various things like submit pull requests, for example, if you like. So if you're not technical, there's no need to sit back. You can also contribute by posting some questions, or you can engage the community. If you've got some areas that you understand better than some people, you can ask or reply to questions on our various channels, social media channels, that is. Yeah, basically you can do contributions in various ways.
That's so true. So there are loads of ways. We're always looking for volunteers and guest speakers to come and join us about those. Today, obviously, we're going to be diving into technically also how we can contribute. So Raphael, I will hand over to you to take it away.
Yeah, so in terms of contributing to code, GitHub is the main place that we do that, both for the on the code side, but then the documentation. And that's true for a lot of open source stuff. And if it's not, it's generally around Git. So through there's a number of ways you can do, as Rushmore was saying. There's issues. So if there's any problem, any bugs that you find, or if there's a new feature that you want, then obviously you raise an issue on there. But there's also pull requests, which is the main way that code gets merged, that we get code from contributors, whether here or external, into the main code base. So if you want to contribute, it's both very good if that's how you would make a contribution, but also if you're learning and you want to understand how the code works better, it's very useful to look over past PRs and to review current ones. So that gives you a feel for the code base and how any particular areas that you're interested in work. And in terms of actually making that, if you're unfamiliar, the best way to do it is on GitHub to make a fork. That would be under your own account. And then, so that would be in the top here to make a fork. And so that would go under your account name. You can call it just CyrilDB. And then if you clone that, then you'd end up with a copy locally. And the way that Git works is that you have different branches. So you can see by default that it's main. But then if you want to make a new feature, you want to make a PR or something, then you want to check out and create a new branch. Let's say, just call this stream branch. And then you can do whatever you want there. And then you'll be able to make a PR that represents all of the changes that you've made in that PR going against the main repo, which will show up in the pull requests tab. So I think to give you a broad overview, I think Rushmore's going to go over the structure in broad strokes of the code base.
Yeah, so if you go to our website under docs/CyrilDB/introduction/architecture, you'll see this page that I'm displaying here. It highlights like the architecture in general. So it doesn't show here, but I will show you a bit later. But at the top level, we've got like the API layer, which covers like your REST endpoints, the Rust and the Rust SDK. Below that, it then talks to the query layer. We also call it the compute layer. So this layer is where your queries are processed before they are sent to the storage layer, which is a level lower than that, whereby the actual storage of your data is done. We support various storage engines like RocksDB, TIKV, IndexedDB, to name a few. So basically, that's the high-level architecture. Before we just wanted to let you know that before we dive into the actual code itself. So Raphael, you can take it away.
Sure, thank you. So I think one of the first ways that I wanted to look at was to go over, in terms of the API layer, was the web API. And so the way that this works is that we have a number of different endpoints, and these are stored in the net module. So there's the SurrealDB. This is all in the SurrealDB binary, as opposed to the core library, which we'll be looking at later. And the way that this works is that you have different endpoints, which are represented to be these routers in different modules. And so if you wanted, if there was something you wanted to add or something you wanted to change in a particular endpoint, that was the code that you would look at. For example, one of the things that I've been working on recently is the RPC module. So the way that this works is it registers on the RPC route a get handler for get and a post handler for post, which are the different methods that HTTP has. So on get, it allows you to upgrade to have a WebSocket connection. And so you see we take the WebSocket, and a lot of this is sort of networking code to facilitate that upgrade. And then you can see that we're constructing a connection from the session and passing this to the connection object. The way that we use the Axum library to run the networking, and this has an extractor pattern, which basically takes any parameters that you pass in the headers, such as authentication, namespace, database, and it constructs an object and this ID out of these extractors, which we've already had. And so we just then construct this connection struct and then serve that. And then, or for a post, we do a similar thing where we basically parse the information out whatever format, because we support several formats. We have JSON, CBOR, bin code, I think are the main ones. So we take those and then we pass them to, in this case, the RPC context. And what this is another example of is something that's wrapping the sort of the internals of the database and is an intermediary layer. So this is one thing that will come up quite a lot, is that there's sort of a layer on the outside and then there's sort of layers as it goes into the core, as Rashma was just showing. And so if you're interested in either fixing something or adding a new feature, it's worth thinking about which sort of layer in this stack that would go to. For example, in terms of executing something, this takes all of the different methods and then it will pass them to the key value store. Here we are. Which is a data store type, which is something that's deeper and which we'll have a look at later. But the main way that the networking modules work, and there's similar, for example, for the SQL, that it unwraps that and then it gets access. You can see the post, it gets access to the data store, this underlying structure, and then it submits whatever you put and possibly does some pre and post processing to do that. So that's the main way that the networking does. I think now we're going to go on to the SDK, I think with Rushmore.
Thanks, Raphael. Before we dive into the SDK itself, I just want to highlight a couple area of entry points as well. So this is the main code base, the main repo of ZeroDB. As you can see, we've got like top level folders here. We've got the core library, then the core library is where the storage engine and the query layer sit. We have the SDK in the lib folder here. Then we've got the source folder, this is where our binary lives. So the other entry point is the command line interface. You can find it here in this CLI folder. And if you drill down, you will see this SQL module here. This is where our, when you run Seru SQL, this is the code you'll be running. So that's one of the entry points. And when you are running the server, you'll be running this module here, the start module. That's when you run Seru start. As you can see, we've got other modules here like upgrade, validate, and all that. So now I'm going to dive into the SDK itself. So this is the lib folder. If you dive in there, you see we've got the examples folder. So I just want to highlight this version example. This is like our Hello World example for SeruDB. It's very minimal, as you can see. Here we are using typed parameters for our scheme, but we've got another version that we call Seru-Any. I'll show you as we go on. That doesn't need to use like typed parameters that you can use at runtime. So this is a very minimal example. We've got other examples here, as you can see. You can dive in if you want to take a look. But basically how the SDK works is you create a connection, as you can see here. Just first create a connection, and then you then run various methods. The version is one of our methods that you run. So if you navigate to the source folder, you will see there's the API module. This is where like most of the implementation lies. The methods that I talked about, you will see them in this method folder. You see the version method I mentioned earlier is this one. So to add a new method, you just copy like this version method, and then you just modify it as you see fit. After that, you go into the mod folder. You then add your method there. Like right now, we are seeing the implementation for the insert method, which invokes the insert module. So the way the SDK works is that I mentioned earlier in passing that we've got a number of storage engines that we support. So what the SDK does is it takes all that, like it abstracts away all those engines in the various ways of accessing your data that we have. We call those engines. So we abstract that away and we make it consistent. So the way you access data when using RocksDB, or when using TechAV, or even when using an external server that you access via WebSockets or HTTP, it's exactly the same way. So we abstract that using the SDK. So the engines that I mentioned are in this engine folder. So this is the Any module that I mentioned earlier. So I just want to show you an example of using the Any module. As you can see, we do not have like this Seru method that we invoked earlier when I was showing you the version example. So we have a connect method in the Any module that you can use to then enter your endpoint that will be interpreted at runtime. I mean, sorry. So as you can see in this module, we've got a native module and the WASM module. The native module is when you run your SDK, like maybe you are embedding it and you are running your application on Linux, directly on Linux, Windows, or Mac, or wherever you are running it. And we've got the WASM module, which is when you're running in a WASM environment, like in your web browser. So SeroDB, the SDK itself can be run in WASM or natively. So we then have these local engines are the engines, the storage engines that I mentioned earlier, the things like RocksDB, GIKV, they live in this in this module right here. So all the storage engines that we say SeroDB supports, they are in the local engines. Then we've got the remote engines. That's where the HTTP and the WebSocket engines live. As you can see, with all these modules, they've got a native and WASM support. So everything is very consistent and interchangeable. It's very easy to change from, like, say, your app is written for embedding, and like you are using RocksDB. Say you want to switch to an external server and connect via WebSockets. It's very easy to do that, and you can even do it without recompiling your code or changing any of the code in your application. You can do that when using the N engine. So when you are adding like a new module, the first thing you do, say for example, you have you want to add a new engine, for a new local engine. The first thing you do is you get into the mod file here, and then just want to show you. Yes, so here we specify an endpoint. This is our documentation. So this is a struct for the memory engine. That's what you saw like as the type parameter when constructing Serenio. So you first define it here. That gives you an endpoint to then hook into and implement your logic for that particular storage engine. Now you're seeing documentation for the file module. Our file module currently is just an alias for RocksDB. We use RocksDB for that. And in here we now have the RocksDB module engine itself. So basically, adding a new engine is very easy because we use a trait. So basically, once you do that, you add your engine there. You just define the struct. You don't need to do much because a lot of it is abstracted away. You then need to add an endpoint. And you find that here under the opt folder. And if you go into endpoint, as you can see, like all these modules that you are seeing here, they are the engines that SeroDB supports. So for the memory engine, for example, if you navigate into this module, you can see an implementation of the endpoint itself. So for the memory engine, we support mem as the scheme, but you can also just use memory info to access the in-memory engine. So basically, that's the high-level overview for the Rust SDK.
Excellent. So I think going sort of deeper and thinking about how stuff inside the database actually works. There are a couple modules that come up a lot, and it's, I think, very useful to understand how they work. And particularly, one of these is the SQL, which contains a lot of types about how things are stored in the database. One of the, I'd say the most important one is probably value, which is in SQL value. And this basically represents, this is the type of any value that we can be represented in the database. And you can see this is a big enum, so you can see we've got things to represent none, booleans, numbers, strings, which are called strand, so that might trip you up. Things which are the record IDs, the table and the ID combination, and lots of other things. So often, if you're doing anything in the internals, you'll almost always come up against the value type and have to deal with it. And so you can also, you have lots of types that sort of represent structures of other values, like objects and arrays. And you'll notice that a lot of these are wrappers for other structs. So for example, an object is a wrapper around a binary tree map, which is one of the very commonly used data structure inside SerialDB, of a string and a value. So if you're dealing with objects, a record, for example, it would be an object in there. And any other kind of thing that would be represented in the database will almost certainly have a module inside the SQL, as well as lots of traits and things to work with them. And if you are interested in looking at the query language and executing things, then the statements module contains all of the AST types for SerialDB. So this is both what's generated by the parser, but it's also what's used directly by some things. So for example, in the RPC stuff that we were looking before, which is what's called by the WebSockets, we can see for we can see, if I can type, let me have a look. But that we, it's manually constructing AST, which we then pass into the database. This isn't so much, but lots of the methods or things that interact with the database. Some of them will use generate SerialQL, which is then parsed into the AST, or you can also construct it directly. And that is in the SQL statements module. So, for example, let's have a look at select, which is a fairly classic one. So this contains anything that you might include in a select statement. So, for example, we have the fields that you want to select, where you're selecting from, things like limits, orders, groupings, whether you're fetching certain records, doing it in parallel, etc. And one thing that you'll notice on a lot of these types is that they have these revision annotations. And basically this is a serialization. It's a macro that, and a library that generates the serialization that we use in the key value store. So we have the key value engine, which basically just allows us to write and get back key values and to do scans and transactions and that kind of thing. And revision is what we actually use to generate the data that we put in there. And it has a version, it stores what version of the struct or enum is on. And so if you change it, it knows that, and when it deserializes it, it checks if it's on an old version, and then it can upgrade that. So for example, I think in 1.3, we had sorry, that's something else. At some point, only was added, which is if you're selecting something, instead of getting an array, if you're only selecting a single record, it just returns that. But this was added after 1.0, after this was stabilized. And so to maintain backwards compatibility, you see that we have this revision start too. So if you're adding or changing anything in these structs, you should be make sure that you have the correct annotations, that you increase the version. So when it's reading files from older versions of Surreal, that just works seamlessly. So yeah, there's every statement that you have in the query language is reflected here. The insert, and a big one is the define statements. There's a lot of different things, and so even though they're all the define keyword, they're separated out into separate things. So for example, define table was something that I was recently working on. So you can see that the if not exists and kind were both things that were recently added to this. And there's also some code associated with these types that actually run it. But I think one thing that I want to go through first is if you have the functionality in the AST types, you know, for the most part, you don't interact with AST directly, you interact with the query language. So if you make a change there, how do you actually reflect that in a way that you can use? And so that's where the parsers come in. At the moment, you can see there's version 1 and version 2. So, and this is in the SYN module. So V1 was the original parser, which is uses parser combinators and a crate called nom. And then version 2 is a handwritten parser by Mies, which is much faster. And they're almost they're basically the same in terms of what they parse. And if you're making a small change, it's fairly straightforward to change this. So if we have a look at, for example, at the define table, now this can look a bit strange at first, but the way that this works is that it's sort of taking piece by piece. That's why it's called nom, I think, is that it's taking a piece at a time out of it. So you can see, for example, in this, that we're looking for a table, makes sense. And then if not exists, then a space, then an ident, which is the name, and then we have many because we have options. So yeah, so what are the options? And then this is basically saying, oh, sorry, I don't want that. Here we are. So basically, these are all the things that you can do. You can have different, say, drop, view, comment, schemaless, schemaful, etc. So if there was some new feature you wanted to add in here, you would, if there was a tag, then you would add it in there. And then you can see that there's an intermediate struct, which basically has options for all of the things which are added. And then so you represent that in the sort of intermediate format, and then you turn it into the final AST. And if we look in the new parser, it works slightly differently. If we look in the same thing, but you can see it's a similar kind of idea, that we're looking for particular things and then reflecting that in some intermediary struct, which we then turn into the final AST. So if you're interested in anything in how the query language works, those are the sort of main places to look in terms of changing those. So yeah, I think those are the main things up until the data store itself, and that behavior is spread out through a number of modules, both in the some is behaviors in sort of in the AST, and then more in the data store side. So do you want to discuss how some of that works, Rushmore, or should
I? Yes, I think a useful thing to, a good tip is when you want to contribute to, or maybe change some behavior on the query layer, or maybe even lower on the storage layer. It would be nice to know like the entry points for that, like as I mentioned, the data store. So here I'm still in the Rust SDK, but I'm showing now how we invoke like the lower level aspects of the database. So as you can see in this in this function, we are taking the data store as the KVS. The data store comes from the core library, which is located in the core folder that I showed you earlier. So here we're calling the process method on the KVS variable, which is the data store. So that's the entry point for the data store. If I navigate to that, as you can see, I'm now in the core library. So in this method, the process is the entry point, like I said. So you can now see how it flows into the lower levels of the database. So we are creating the executor here that we're going to use later on. Here we're not just creating the context. Here we're just setting up stuff. Here we're just creating live queries. We're setting up notifications for live queries. Just attaching the context is still setting up, like I said earlier. Here now, this is where we now go into the executor. So if you just follow that, like the execute method here, we're now in the executor method. So this is how you can go about it if you want to dive deep into the lower levels and contribute at that layer. You can just sort of follow the code to see where it takes you until you get to the point that you actually want to edit. As you can see in this method here, we are iterating over the query that was sent by the SDK, and the query itself is a vector of query statements. So that's what we are now iterating into and inspecting each statement. So now what you see now, we're now operating on the individual statements themselves. This is the option statement. Because the statement is an enum, which just enumerates all the various statements. The begin statement, we're just beginning the transaction. So, like I said, I just wanted to show you this so that you can see how you can dive in and start following the code to get to the area that you may want to edit. Like, for example, if you want something to do with transactions, you can see here the begin statement, say you want to edit like the behavior in here when creating transactions. So if you create begin, and you can see the transaction type here is what we entered. In this particular case, we had transaction type being right, and the transaction method itself. So you can do this like following the path using your IDE. So this way you can drill down to the point that you want, and then you can change the behavior however you see fit. So that's just what I wanted to point out. So it becomes like a bit clearer, like how you can locate the areas that you may want to edit.
Yeah, and I would just like to reinforce that, because that's how I started on this and other things. If there's looking at the API servers, following things down, the sort of modern tooling is really nice. You can just click on stuff and go through and see where it's defined. And that's a really powerful tool, both in SterilDB and any other project. And I think that's one of the best techniques for, as a sort of outside user going in, because that allows you to see the critical path that you're using. What's a function that you've called, and that's also I find that useful, not just in contributing, but also debugging or understanding how I'm interacting with something, is following what's the internals, and that's a really good technique for that.
It's so great to see, and it's great to see some of the comments, Rushmore and Raphael. Thank you so much. It's one of my favorites. This is awesome. I've worked on some large open source projects, and trust me, people get afraid of looking at all the files and folders. So really brilliant to have walked that through. This comment continues. So thank you for helping it look less overwhelming. Anyone watching now, if you have any few final questions for Rushmore or Raphael, please do just pop them in the chat. It's been a really great introduction to the code base. Another shout out to Alex here. Like your product, and also we're really active on Discord. The whole team's on Discord. Our brilliant DevRel team and all the engineers are really there to help. So I'll share the link in the chat now. Do come join us. I think we're so close to 25,000 stars. I think we're about 50 off. So who's going to be the final one to do it? I don't know. Raphael, Rushmore, any kind of closing comments? Everyone is so handsome on this stream. Wow, look, the comments we're getting. Team.
Yeah, the main thing that I would say is, if you are overwhelmed, and I know I'm pretty new to this, the main thing that I would recommend is just start reading through as much stuff as possible and asking questions. Any projects that you're using or interested in, most communities are very open to new people. I know that Strill definitely is. The Discord is an amazing place. So if you're interested in, start reading and start understanding, even if you don't have any specific features in mind or are trying to do PRs. The idea, getting involved and understanding things better, and getting used to that is a really good skill.
Yes, just to add to what Raphael said, basically, if you've got any questions, just hop over to Discord and ask your questions. And I just wanted to also address this question in the comment section. There's a question asking, so SeruDB is not a real DB? Is it just an abstraction over the other databases like SpeedDB, TIKV? Yeah, so SeruDB, it does abstract over all those various storage engines, but we also have SeruKV, our own key-value store that we are working on. So we are not just abstracting over these already out there data stores, but we are also even diving deep, also building our own key value store.
The other thing I would say to address that is that, for example, SpeedDB is not a database in the way that I think about it, at least. It's not something that I can query. It's a key value storage engine. It's something that allows you to write a key and a value and to say, what's the value associated with this key, or to do a range scan and transactions. So all of the functionality to do with querying graph links, record, or any kind of those sophisticated things, that's all in SerialDB. And that's how every other database works. You have the storage engine and then all of the logic on top of that. So at the moment, we're using other key value engines, but as Rushmore says, there's a lot of exciting work on SerialKV happening.
Rounding up there, thank you so much, Raphael, Rushmore. Thank you for all the comments from the community as well. We will be back for SerialDB stream number 22 with our co-founder, Toby Morgan-Hitchcock. That's going to be for the next release train, so we'll be diving into the latest features that we've been working on, and also do hop on the rest of our YouTube. We're starting to release SerialDB in 3, which is really bite-sized content, and as we said before, please do come say hi on Discord. For anyone who's just getting started, we have a database 101 channel, so you can literally ask any questions you have getting started there, or you can really deep dive into the specific channels as well. Thank you so much, Rushmore, Raphael, thank you so much too, and we will see you all next time. I'm going to play us out. Thanks.
Bye.
Thank you, Izzy. Bye, guys.